Welcome to the Analytics Engineering Podcast, featuring conversations with practitioners inventing the future of analytics engineering. Anders, welcome to the Analytics Engineering Podcast.
Thanks so much for having me. This is fun.
For everyone listening, Anders and I have worked together for, Anders, how long has it been now?
Yesterday was 4 years.
Ooh, congratulations. Happy anniversary.
Thanks.
So yeah, hang out a lot, know each other pretty well. But Anders, why don't you take a minute to introduce yourself to the audience?
My name's Anders. Like we said, I've been here about 4 years now, and I would describe myself as like a hardcore data nerd, in the sense that it's kind of the thing in my bones that gets me going. Gets my day started. I am so excited whenever on Hacker News like a new query engine pops up or some new format. I'm so excited. This all began like way back when I was like, first I was a math teacher, but I got into data and analytics. I was doing data analytics, data science, found DBT, was in the community, came that way. I've just been always very excited about like what the future may hold. And I think I sort of have like, I'm infamous internally for being the green hat, like what if data were like this person internally.
The math teacher to data practitioner pipeline is very strong. I think, so we have you, we have Kyle. Is Faith also an ex-math teacher?
Yeah, Faith was one. I'm trying to think of the others. There's quite a few. Emily Rockman is a software engineer, but like is here and was a math teacher for a while.
So I wanted to have you on the show today because of some work that you've been doing internally to kind of summarize the state of the Iceberg ecosystem. And on the podcast, we've talked about Iceberg a bunch of late. And it's usually with people who have a lot of knowledge about a very specific part of it. So maybe you're an expert on Iceberg, the open source part. Maybe you're an expert on Snowflake's integration with it. Whatever. Like we've had all these different conversations. But the work that you had done was kind of a summary of the state of the Iceberg ecosystem, where we're at with platform integrations, what things feel easier today than they did a year ago versus what feel hard today still. So I wanted to get your expertise on this kind of more overview. Before we dive in, I wanted to get you to define a few terms so that we can use them in our conversation. So I'm just going to hit you with a lightning round. When you say query engine, what do you mean?
I say query engine, this is the thing that does your work. When you issue like a create table or a select statement, what is the thing that's going to go do the work to either like return you data or save it, store it somewhere else for later? Like this is the thing that you interact with that does the work.
Okay. Object store.
Object store is one, it's not a phrase that I really like. Often most people say like S3 afterwards, but it's the thing. It's a cloud service where you can store an object. And like, what's an object? An object is, think of it as a file. It's not necessarily a string. It's anything. It could be a blob, which is the word used.
Got it. Catalog.
A catalog is also a very overloaded term in the data industry. But in this instance, like in the context of data warehousing specifically and a query engine, a catalog is the thing that knows what tables exist, what views exist, what objects exist in your database, and like where they are and where they might, how they might be fetched or how you might write to it.
So let's move into talking about catalogs, and let's specifically talk about internal versus external catalogs. This is a concept I think that has become used for all of the major data platforms. But a couple of years ago, when we first started talking about Iceberg pretty broadly in the ecosystem, I don't think that this was like a concept yet. So I think the idea is that, the Snowflake and Databricks and others have catalogs that they use internally, and that if you just kind of sign up to the service and start using it, like you just get a catalog by default. whereas an externally managed catalog you can kind of bring yourself and plug in. Am I getting that right?
Like an internal catalog is when you are just working with SQL Server or Snowflake, it's where's the data coming from. An external catalog is just like another directory. And I think for a long time it didn't exist because of Spark and because of separation of storage and compute. You started to add different things like Hive Metastore, which we could talk about later. But the idea is that it's not the thing. Maybe it's managed by somebody else. Like the Snowflake catalog, that is the one that's built in, Databricks' default Unity catalog, those vendors manage those catalogs. But when you want to start connecting other data platforms and disparate systems together, you can't always be in control of everything. And I think that's like maybe a better definition of what an external catalog is. It's like something that's not necessarily managed by the same service as the query engine.
The complexity involved in internal and externally managed catalogs often comes from the fact that previously, before the kind of widespread usage of externally managed catalogs, you didn't have to think about duplication. If you referred to a given namespace, there was only one catalog that was responsible for resolving that namespace. You knew that it was going to be unique. All of a sudden, it's hard to guarantee that namespaces are unique. How does this work? Like, is there a kind of primary catalog? Can you plug in 10 external catalogs to your data platform? How does this work?
I'm a big believer in the power of abstraction, right? And you don't want a leaky abstraction that sort of like halfway works but then breaks. You need something that's like pretty solid. One common pattern that you see with these like external catalog integrations that's like emerging, and especially in the past year, is with the advent of like catalog integrations, is there's sort of like a one-to-one mapping to like as analytics engineers, we know about like database.schema.identifier. And so I think there's been like a movement to sort of like try to directly map an external catalog into a database. Snowflake does something like this. Databricks is sort of like Lake Federation, same sort of concept. Starburst has done this for a long time. Even Spark has this, where I think they added like a 4-part namespace. It's like, hey, here's catalog.database.schema.identifier in Unity catalog.
So we used to have a 3-tier hierarchy, database, schema, table, and now we're getting a 4th tier.
Yeah, it's funny how full circle it is, right? Like I remember in the early days of Spark, there wasn't 3. This was a big challenge for us with the DBT adapter for Spark, is that like you don't get a database, you just get schema and identifier, and that each Spark cluster sort of had its own effect, was a database, was a catalog in and of itself. But now with Unity catalog, this is where the word Unity kind of comes from, right? It's like this was a fundamental limitation of like the Hive Metastore. But like now, how do we combine multiple metastores? Like, oh, we need something like a catalog, or now you have multiple catalogs. Like, how do we unify this experience? And like, what does it look like? This, like, I think in my dream world, if I could envision like what it is that analytics engineers want, like at the end of the day, like it would be a very convenient abstraction if you could say like, oh, analytics database, like that's our internal thing, but like there's a finance analytics team and we're going to make a database called finance analytics. And when I write tables there, like it's made available, it's an external catalog, but that's all that you need to think about. Like that high level of abstraction, I think is like really powerful. But like inevitably, like there's no such thing as a free lunch, and you get into some tricky trade-offs where I think a lot of the platforms, and especially in the past like 12 months, have been like really innovating on like how to make that abstraction simple and work, but also robust.
So you mentioned catalog linked databases, Snowflake's new feature. I think that this is Snowflake attempting to do it exactly the way that you just described. Is that fair?
Yeah, I'd say so.
So as a user, you can kind of forget where the catalog is configured or where the files are stored or anything like that, and you can kind of treat the tables and schemas the way that you would otherwise. Great. So like, what's the downside? Is that all cake and you just get to eat the whole thing?
Yeah, I wish I'm a big cake fan. I wish it were all cake, but the devil's in the details, as they say. I think like when I first started hearing about this, like when we talk 18 months ago, would have been like the data conference summer season of 2 years ago, the year before last. Like there was a big excitement about Iceberg and the promise of what it was. And I felt myself like very antsy to see like our platforms deliver this so that we might like share with users and like enable people to have like really easy integration across catalogs. But the more I worked with our partners and vendors in the ecosystem, you come to realize like how challenging this is, and that how one great example I think is about like we can explain like just really quickly like an information schema. This is something that's like likely familiar to most like analytics engineers. Like how do you get all the tables that are in a certain schema? You say like select star from information schema dot tables where schema equals something, and you get this long return. Even like there's a lot of complexity just in that when it comes to catalogs, because basically you're going to get all the tables that exist. Where is that stored? Like there needs to be a separate metadata service. You can't just like go to object store. You need some consolidated cache of where this information lives. And users have an expectation, like people would get angry if you make them wait 10 seconds to just list tables. Like there's an intuition that we have as analytics engineers, like this should be very performant. And it should never go down. Like if that information schema isn't available one day, like dbt is dead in the water. Like you can't, because you can't create a table unless you check to see if that exists already. So you need this metadata catalog service needs to be like performant. It needs to be like very resilient. And so traditionally, I really like the metaphor of race cars, thinking of databases as race cars. Like they are tuned. This is like an essential component that needs to be very fast because it's used for so many different things. So then we get into like this externally federated world where like, oh, now there's 100 tables that are outside of the query engine's control, or even like the vendor that you're working with. And when you say, I want to list all those tables, how do you performantly do that? Like how you have to, it's one of those scenarios where as a vendor who's allowing your customers to connect to other places, even if this external location is really slow and not performant, like you as the vendor, you're on the hook when people are upset. They're like, hey, I'm trying to list my tables and it takes 5 seconds. It's not, the customer's not going to like it when the vendor tells the customer like, well, it's actually because like they're not doing things differently. Like the expectation with this abstraction is like, oh, it's in a database, I can just select from it. But like performance becomes like a big deal, especially when like there's thousands of tables in these external catalogs. So how do you manage it? Like I think one great example is like DuckDB's Iceberg functionality has come a really, really long way. But one limitation, like maybe even a constraint, an intentional constraint of DuckDB today, is that when you attach an Iceberg REST catalog to DuckDB, it won't show up in select information schema.tables. Like you can describe that specific table, but there is no way to give me all the internal DuckDB tables and external in one single call, because they say like there's no way to make anybody happy here. So they've drawn a line in the sand. Whereas Snowflake with their catalog linked databases, like my understanding is that they have like sort of like a caching mechanism by which to bring it into the internal metadata service so it feels just as performant as like an everyday Snowflake table.
You add functionality and then you realize that functionality makes you require more functionality. So like previously, the as you described it, metadata service was kind of one-to-one with the catalog. And so if you asked, tell me all the tables, then the metadata service just asked the catalog, what are all the tables? And now, you can imagine a very large data platform deployment with many different linked external catalogs. And so every person that is going to go out there and, list tables is going to have to in real time query, a dozen or more externally linked lists of tables. Like that's not reasonable from a performance perspective, as you mentioned. So yeah, my understanding is with catalog linked databases that Snowflake's actually doing a bunch of mirroring. Is that right?
I believe there's mirroring, and this exists. Databricks does some concepts of mirroring in partnership with OneLake. Like there's different ways you can approach this, right? Like even Snowflake before catalog linked databases, they were like mirroring to like a hosted Polaris account. Like this is another way to deal with the metadata. And even inside of distributed query engines, like eventual consistent state across all the nodes of distributed query engine, like this is a similar sort of problem that you can solve when you own everything. But how do you effectively negotiate this? This is where it's a challenge sometimes. A lot of folks will talk about the Delta file format and like a Delta catalog as simpler, because you don't need a catalog service that's an API. Like the source of truth is always just inside of object store. So like, hey, you don't need this metadata service that's standing up. You just tell the query engine to look there. There's one file, tell you the latest thing. But there's like some big limitations that come with that. Like you need this metadata service. Like you said, like it's in some ways, it's like a champagne problem. It's like a problem that comes with success of people saying like, we need these federated catalogs working, is that how do you, for example, have two query engines write to the same table at the same time? Like as soon as you want to do something like that, then the notion of like not having a metadata service to talk to these external catalogs like kind of goes out the window. So we need this catalog, and yet you go.
Everything that we've talked about so far could just be, I have one primary data platform, and yet I want to bring my own catalogs. But we can step into the world where that I think is actually quite common, where an organization will have multiple data platforms and want to use open table formats to share data across them. That is, you take all the problems that we've talked about so far, and you layer on top of them that there is a set of features that needs to be supported by either the reading or the writing platform in the shared Iceberg catalog in order to make all of this work seamlessly. So can you talk at all about the state of the ability of different data platforms to kind of read and write transparently to the same Iceberg catalog?
Yeah. I think it's like it's
big sigh before we dive in. Yeah, it's a complicated topic.
Well, you think about there's sort of like phases of integration that we see like data platforms adopt when it comes to Iceberg. The first one is sort of like a naive approach, is to be like, I have a folder of like Parquet files and some JSON. This is what an Iceberg table is, and I have it in Blob, and I want to read that data in my query engine, or maybe I want to write to that place. That's kind of like a, as far as things go, as far as like integration and complexity, like I feel like we've seen most query engines as they begin to adopt Iceberg, you start with that. And specifically like reading is even easier than writing. So you can like read and write to a single table. And I think as like a toy example, like you can get that working, like, oh, I see how this works. But like inevitably you run into the first sort of like set of complexity challenges that you run into is sort of like, say I have an upstream team, like there's a central data team that has their query engine and they've written to a catalog. And now another team somewhere else in marketing or in finance, they want to read that data. We get into this problem of versioning. Like, how do you know who has the latest version? Or what's most important? Is it most important that like this downstream team can get the data as fast as possible, even if it's not as recent? Or is it always, do we want them to always have the recent data at the expense of like performance? And so like already just like one table and one catalog were in these weird. So the initial integration that was rolled out was like the downstream data platform would have to say, no, here's the new JSON file inside of Blob that gets you to read it. And for me, like my spider sense goes off here, my spidey sense, in that like it's kind of messy. Like in my ideal implementation, like us as analytics engineers, we should never have to think about like S3 paths and which JSON file. Like it should be as simple as like database.schema.identifier, like select star from it, and there's an implicit assumption like I'm getting the latest data here. So like the next phase that you would see was something more about this is where we needed an Iceberg REST catalog, because one of the things that it does as a metadata service is, hey, what's the latest version of this table? We know a lot of these features already as things that were shipped as like platform capabilities, like time travel in Snowflake and in Databricks and BigQuery. Like these are like well-known features, but under the hood, it's actually like we now are fortunate to have open table formats that implement this. So like you need to be able to have version tracking and history, updated versions. So once we get beyond this like naive reading from the phase one of reading and writing to object store, we get into this sort of phase two to say like, okay, we agree that we need this metadata service. And there's this Iceberg REST catalog that sort of like came to the forefront of everyone's like brains as a result of like Tabular joining Databricks and the great work that they were doing. now we have the second phase of integration that data platform vendors have taken with Iceberg is like connecting to an Iceberg REST catalog. And the win that you get from there is like you no longer have to think about object store at all. You're like, hey, give me this table. Sometimes there's like a refresh button, but even then you don't need that. Like the query engine can kind of abstract and always just like give you the latest version of that table. So the limitation in this is phase 2, but I can keep going. But any questions right now?
No, go for it.
So that's, I would call phase 1 is the naive reading. Phase 2 is like, hey, we can make a single table and keep you up to date with the Iceberg REST catalog. But I think that the higher order one, the phase 3 that we're sort of seeing come over the finish line now, like with what you said about like catalog linked databases and like Unity catalog and like OneLake's mirroring, all of these capabilities that exist in most of the platforms is, okay, now it's never that you need to share. As someone who's had to share teams and talk about marts and complicated architecture diagrams between different teams owning different data sets, it's never a single table that you have to share, right? You have to share like, it's not like a dozen is pretty common, because especially if it's star schema'd out. So you're sharing not just one table, sharing multiple tables, and then often that team is going to modify some of those tables. You need to read those back. We need a way to like make it really easy to not just add and keep one table up to date, but like a whole schema of them. And so in this world, we need to like the query engine and the data platforms have to like automate discovering, hey, this schema has a new table up here. I'm automatically going to, without the user having to intervene, like expose that for the user so they can see it when they're browsing what data is available, keep it up to date. And like maybe also things like multi-table transactions. Like I want to update both of these tables at the same time. If one of the statements fails, I need to roll it back. That's sort of like the phase 3 that we're seeing like integrate. And like the phase 4 is sort of like the newest version of the Iceberg spec that's being discussed. Things people talk a lot about, like we can get into later, things like the small files problem and like automatic cleanup and maintenance of catalogs. But I think given that those are the 3 phases, and I'd say that like the platforms that are like really investing in Iceberg are like clearing this 3rd hurdle, whereas some are still struggling in like the tier 2 area still.
I don't know if this is unique to us, because obviously I have a very DBT-centric view of the world, or if this is a problem that lots of folks are spending a lot of time thinking about. But we have this feature called DBT Mesh, where you can be either the producer or the consumer of data products that are defined in a DBT project. And a very common way that people want to use this is what we call cross-platform mesh, where you can be authoring a data set as an upstream producer, and a downstream user wants to consume that as a part of their DAG. They want to read from your data and then further transform it. We have run into all sorts of interesting permutations of like how do you effectively make data available in another platform using open table formats. And it's like, I think you referred to it as the producer model and the consumer model. Is that do I have that right?
There is a way, like you can talk a push-pull consumer producer, right? There's a world where when I was talking about the phase 2 about of like the Iceberg integration in Snowflake, the way they originally shipped it was, hey, there's some table in an external catalog that you know about. First, set up like the bridge so you can talk to the catalog. Then, for every table in that catalog you want to access, you have to write a statement that's create Iceberg table. And then you give it a new name. And then in the options you refer to, like, here's what it's actually called in this other catalog. And then you issue that thing. And only after you go in and fire off those statements are those tables available and you may query them. And like, from a practical standpoint, like that's the right thing to do first from like the vendor perspective, but it's not, for me, it didn't meet the criteria for what we thought would be like an ideal experience for like facilitating like what we call cross-platform mesh. Because what that means is, I think if you come back to the socio-technical problem, like you could imagine this upstream team like sending an email, right, to say, or like a Teams or a Slack message to say like, hey, the data's there, you should have it now. And like, but that fundamentally not being true, because no, like this downstream team has to go in and create the pointers themselves. Alternatively, like you have to give the upstream team like access via credentials, like maybe a service principal, so that they may write like they may do that work for you. Like it's a little bit messy there. Like on the one hand, it's simpler from a vendor implementation standpoint, but it's rather messy. And when we did the first implementation cross-platform mesh, we were envisioning like this upstream team, the TBT project might auto create in the downstream. But I think the producer-led model is a lot cleaner. The producer-led model is like, of course, where you can just write directly to a catalog from the upstream. And it's just there. There's no operations in DDL, DML. Like as soon as that producer writes, like if I'm in Databricks upstream, as soon as that create table statement finishes in that external catalog, like it's available on Snowflake. And I think that's like a much cleaner process.
And is that where we're at today? Can you use the producer model? Because I completely agree on the socio-technical problem. Like you as the upstream, when you produce the data set, that should automatically flow to your users. That's how it works when you're all sharing the same data platform, the same catalog. It seems like that's how it should work also when there's an external catalog in play. But are we at a place where the main data platforms support a producer-led model?
We're in the place where some platforms support writing directly to external query engines or external catalogs. And in these use cases, like it's great when it works. There's still some kinks to be worked out. Like there'll be lots of inevitable hangups depending on the catalog that you're writing to. Like if you can do like create or replace versus just create table then truncate. There's like some API things that like SQL API things that like we as DBT are like very well versed in like papering over. But when that pattern works, it's great. I think that the challenge, that the work that's been happening over the past 18 months, like a big question that people will say is like, hey, we've been talking about Iceberg, but like, where are these users? But it's like back to that race car metaphor. Like we are retrofitting a bunch of race cars that have been designed just in isolation to be as performant as possible, but now like gutting it out so that like a query engine may write not just to itself, but to other places and to have like sort of like comparable performance in a way that doesn't like distract us from like delivering insights to our stakeholders.
One of the hairiest things in the Iceberg ecosystem right now is identity and auth. There was some good news on this over the past year, I think. I think 18 months ago, I didn't really know the term vended credentials, but then very quickly became aware of that. And it seems like there's been a lot of progress there over the past 12 months. Can you explain what the heck is vended credentials and what problem does it solve?
Going back to sort of like there's a simplicity of like what Delta offers where it's just object store. And then you're like begrudgingly admit like, okay, we need a metadata service. But ultimately like that metadata service, it's like hard to envision a future where this metadata service, this catalog doesn't have some auth and identity built into it. So then like sometimes you get to the point where you're thinking like, well, a catalog is actually just like a data warehouse that you expect from a data warehouse, but without a query engine. And by that, I mean like, there's a lot of discussion.
Many of it, because a database is not one thing. A database is like 13 things.
Yeah. And I think one powerful abstraction that is incredible are grant statements, right? Like that you can say, here's the table, here's the groups that should have it, and that's just done. And when you're living within just one data platform, that's great. But as soon as you start to think about like, I in Databricks can like, in Snowflake, I can write to Databricks catalog, but I have no control over like the permissions of who sees it over there. Like even if we're using a producer model, we would have to pre-configure setup. There's some work to be done to make sure that like the right people see it. Whereas like the things that have been baking in the oven for a long time, like the Delta sharing and like Snowflake Secure Share, like because grants on either side are both the same platform, like you can roll with that. So the question is effectively like, how might we, if we decide we want to be using multiple platforms, maybe multiple catalogs, how do you have like one source of truth for who should be able to access something and who shouldn't be? And when the original REST API spec came out, it's like, oh, we'll just use like, the OAuth 2 token spec, like, which is, you could think of as a service principle. It's like a password, but that's not very ideal or enterprise ready. Like we work with lots of customers who have like very strict, enterprise like auth identity standards, and like the vendor platforms have those built in already, like SAML integrations to things like Okta, etc. But the best that we have right now in the initial Iceberg spec when it comes to vended credentials, the need for it was when the metadata service is separate from where the data is stored. So like, hey, I need to have a key to go ask this catalog, hey, does this table exist? And if I don't have that key, I can't even talk to the catalog. It won't tell me anything. So first I need one key to ask the catalog, does this table exist? And where might I go find it if it does? After that, like the catalog, if you have access to the catalog, it'll tell you, oh, here is where in S3 or in Azure Blob this table lives, so you can actually go read the data and start working with it. The challenge that Vended Credentials solves is that you actually need a second key. You need authentication to the object store to get that data. And that's messy. It's not a clean abstraction, right? Like to have two separate auths. In some ways it makes sense. It's separation of concerns. But in my like magic wand utopia, you just get one, you authenticate to the catalog gives you access. And that's what vended credentials are. Like, so the word vend means the catalog will create a credential for you so that you can access that without needing like a separate access to like the actual like storage location.
Which is a problem that, as a naive user of databases that kind of package all this functionality up for you, I had never really thought about, how do I actually get access to the files on disk required to, perform this table scan or whatever. And so that was a problem that I had not even been aware that I had. And so now I think vended credentials is making progress on that. But user identity and the mapping of users to should I be able to read this data or not is not solved by vended credentials. And I don't, is there a proposed solution in the community? Like does Iceberg even want to deal with that problem, or is that going to be solved by the commercial platforms and their integration strategies?
For me, this is something I spend a lot of time thinking about, right? Like what's missing to have this to work as it needs? On the one hand, like authentication seems separate from the data problem and from like the Iceberg spec. Like there are those in the Iceberg community to say like this stuff. It's like, why must we talk about this? Because like everything about how we write the data and we read the data, this is covered. This is amazing. We have all this goodwill. We're all working on this together. But then people kind of like, it's like, Thanksgiving with the in-laws. People bring like their cousins and their aunts. Like it gets really complicated because you actually, in order, like a data warehouse without like authentication and identity, for me, like I don't think you can call that a data warehouse necessarily. Like there is like an inbuilt abstraction of like access and governance that needs to come with it. But in doing so, like we're talking about multiple public clouds, we're talking about people who are self-hosting, and every company has their own identity model, whether it's like the Microsoft Entra ID or if you're using Okta. Ideally, you'd like to grant data access to a table once, and no matter what platform you're in, like that like global identity is what manages it. And there are some proposals for how we might do that. But I think it's starting just from like what is the key to log into your catalog look like, and how might you bring like Okta to like an Apache hosted Polaris. But that's still short of what you and I are describing, is to say like you and I are in the same large organization and I'm on one data platform, you're on another. I want to write it and say like Tristan should be able to have to query this. And you can't necessarily do that today. The best I can do is like, in your data platform, someone is an admin who has access to these tables, and like they need to go and like create a grant specific statement to you that like I probably don't know anything about.
That it is, one of those things that, longtime database users kind of take for granted, the grant statement. And the grant statement is just like so incredibly simple and powerful. Just because everything is all a part of this same platform, you kind of it's pretty straightforward. You don't have to think about like, how do I coordinate different roles or access levels across many different platforms, which requires everybody to conform to some standard mechanism. But
when we come up with this boundary of like data, sort of like this data engineer persona that we think of versus like an analytics engineer, I feel as if like the analytics engineer has been very comfortable in the world of grant statements, right? Whereas a data engineer for the long time, if you're using Spark and like S3 and you're writing like, Parquet files, like the IAM credential that's inherent of like, a data engineer self-titled would be like a lot more comfortable with this, like the absence of a grant statement. And yet like, it's kind of my strong belief that like, if we really hope for Iceberg to be like more globally adopted, like we have to solve and provide this grant abstraction, because there's a lot of work that we as analytics engineers and data people have to do, like having to like organize and orchestrate your own auth and keep it in sync across services is like not one that feels like a good time investment for end users.
The DNA of Iceberg originally came out of big tech. I think it was originally Netflix, but then it was picked up by a bunch of other big tech companies. And within that context, those companies probably didn't need it to serve all of these different use cases. Like, original Iceberg was just like, I've got a table format. Now I want to be able to operate on top of that with multiple different engines, and I want to be able to solve multi-table transaction problem, like this type of like database type operation. But then now it's because it's kind of captured the zeitgeist over the last couple of years, it's getting pulled into all of these other places. But would you do you see this kind of as mission creep from what the original goals of Iceberg were? Or
I love Ryan Blue said something to the effect of like the reason why these table formats exist. There's a great video of like Ryan Blue and the folks, the Delta team, like the folks who wrote the original spec inside of Databricks, is like the goal here, I think, from the highest level of Iceberg is to just like really optimize down the number of people who have to think about S3 and storage, right? And you could call it like a difference, but I think like at the high level, the point still stands, right? Like at these big tech companies that you mentioned, right? You'd see teams called data platform teams with like dozens of engineers on them, right? And so like a handful of people's jobs would be like, how do we deal with Hive tables that we don't actually get ACID compliance, and like inventing these workarounds to kind of make it work, right? And with Iceberg, if you get these guarantees out of the box, like you kind of get to shift that investment away, right? Right now, what we have, like for an analytics engineer, right now you don't have to think about this at all in this walled garden. But if you want to start really leaning into sort of these cross-platform mesh scenarios, someone on this team needs to pick up these skills and do that. And like we've already seen like an order of magnitude probably reduction in the number of like engineering hours that need to be invested over time to like maintain like an Iceberg catalog versus what was required to do like a self-hosted like Hive metastore, for example. And I expect this number to keep going down. But like we've transitioned certainly in like what does it take to make it 0 engineers time in a month is considering like how the catalog is working. Like there's still work to be done. Like I think that long tail is still like auth and mirroring and those things.
I'm really curious about how all of this reshapes the way that data teams work. So there's so much there. I mean, are we going to ask more from analytics engineers? Are we going to take data engineers and make them into data platform engineers? Any of this, I think is so fascinating.
Can I throw it at you? Just like how do you think? What did data teams look like, you think, before we had sort of a persona or of like a job title of analytics engineers? Like maybe we talk about describing that shift, because I imagine it'd be kind of similar to what kind of makeup would you see in 2016? Like what would a makeup of a data team look like?
So I feel like the most poorly defined role in a data team has always been data engineer. And I think the real like job description of a data engineer is just whatever technical stuff needs to get done that the other people don't know how to do. And that, as tooling evolves, the answer to like what is in this grab bag of stuff that needs to be handled by someone more technical, like it changes over time.
Yeah, there's like no bottom, right? It's like it's sort of like the depth is like to say like this is the person who will like get to the bottom of it and get something stood up. I agree.
It used to be that like essentially, pre-analytics engineer, the data engineer and the data analyst were the only two roles, and the data analyst was in Excel or whatever, and the data engineer did everything else. And then over time, DBT and analytics engineering and Fivetran and et cetera come in, and like you start to pull some of that stuff where the data engineer doesn't need to do it all. But this is now like increased scope, increased complexity.
Yeah, so we've had like I would like the analytics engineering arose like the I think it's a powerful abstraction is what TBT is as a framework that allows like you to get a lot of work done without having to go too deep and like stays focused on like shifting left towards like delivering value, etc. And I think in data engineering the same thing largely has happened too with like, orchestration frameworks, like vendors that do like will replicate your data. A lot of problems that were always just like hard, spend lots of time to do, moving data from A to B, like those things have simplified over time. And so like what's remaining now is, and why we're so lucky with Iceberg as this new abstraction is that it like actually allows you to enter a new realm without having to do all of the work that like you mentioned these sort of like big tech companies had been doing over the past decade to like maintain a data platform. So like the data platform team as a job description, which always used to fall under data engineering, I feel like is also becoming a lot more simple where you could have a team of just a couple engineers. And I think from my observations, we're pretty lucky that you see like when we talk with our big DBT customers, like a lot of them will work hand in hand with sort of like infrastructure as code teams who are working with Terraform to manage their Snowflake deployments. Like there's a lot of teams that already have sort of like the skills in place to sort of tackle the state of play of Iceberg today, which means like owning identity and object store and connections. But for others, that there's certainly like there's room for growth to feel really comfortable with like IAM identity and S3 access policies even if it's enough just to understand and kick the tires on Iceberg, I think that's like a great learning opportunity that sort of like points to the future skill sets that will be required in data over the next like 5 to 10 years.
What's your read on the overall trajectory? So there's of Iceberg, of how vendors are supporting Iceberg, like the entire vision of pulling data ownership outside of walled gardens and into customer controlled environments. Do you feel like, I mean, there's kind of two different extremes of the world that I tend to be focused on, but maybe there's other dimensions too. One of them is that all of the data platforms wholeheartedly embrace Iceberg as an amazing innovation, and they want to support it with the best interest of customers at heart and in every decision that they make. And the other one is a much more Machiavellian like attempt to do just enough to get marketing benefits out of this term, but actually hobble the implementations. Like, are we on the good version of the universe or the less good version?
The amount of like innovation and like industry goodwill that we've seen over the past like 18 months with respect to Iceberg is sort of unprecedented in my opinion. Like considering like an
Say more about
on-premise.
that. What makes you say that?
I just think about what would a data warehouse migration look like, on a mainframe, right? And that's like a years long enterprise project, right? Or even like a data warehouse migration like 5 years ago compared to today, like how much simpler? Like I guess the metric would be like how much lock-in you might perceive between platforms. Today, like the usability of Iceberg still has a long way to go, and in a large part, it's because we only have like entered this problem space because we've solved previous ones. Because Iceberg exists in the Iceberg REST catalog, we're like, we're given the gift of more problems to solve. But that's not a bad thing. That's actually like a good sign that we're here, that we're talking about what identity looks like across multiple data platforms is a tremendous privilege, and it like wouldn't happen were it not for like all the major vendors at the very least like shipping Iceberg minimally, but some are like really advancing the standard. Like it is a very cool thing to have an industry come together to work on a standard. Like these are F1 race car teams who are all deciding like, this component of the F1 car, why don't we all just standardize it so we can just innovate elsewhere and we just like don't have to think about it. Even if that's not immediately available to like end users, like this feels like an optimistic timeline in a time where it's hard to be like an optimist on the future, like for me generally macro, but like at least in the context of like the data industry is aligned and it doesn't feel like there's a lot of like backstabbing or like foot dragging going on. I will say there's like I have a lot of respect for all the vendors as I work with them and I meet with them. Like they have their work cut out for them to be like how to design experiences that like work just like their really great native experience, but also with external catalogs.
I want to close reading you back a quote that you wrote in the document that you published internally, because I think it's a fascinating quote and it gets to some of the dynamics you're getting into here. So the quote reads, "The making of a treaty is the treaty. It doesn't matter what the terms are, just that there are terms. It's the goodwill that matters. When that runs out, the treaty is broken, whatever the terms say." And I had never heard this quote before, but apparently you read different books than I do. This is by Thomas Cromwell, and so I would love for you to talk about this. Like, how did this quote end up in an internal Notion document about Iceberg?
One, it's can't recommend this Wolf Hall series enough as like a big fantasy nerd. I can't, as a big fantasy nerd, it's kind of like the best fantasy book I've ever read, even though it's like historical fiction. Very heavy recommended. I think what's interesting is, I've been in like partner essay sort of role where I meet with a lot of our partners. And when I joined 4 years ago, it was like the rule here at DBT that like you never mention another partner. Like another, like if you're with one data platform vendor, do not bring up this other data platform around them, We are very much like stepping on toes around each other. And, from our perspective, people would be like, how do I get something from Snowflake to Databricks? And you would never find on Snowflake's website how to connect to Databricks and vice versa, right? It's so telling to me that even in the past like 2 years that you'll see a lot more of this now. There's a lot of goodwill to say like, we all have mutual customers. There's a lot of overlap. We want things to work together. And like that for me feels more important, and that we're willing to work on these evolving over time. Because you could imagine like someone sort of like tanking a lot of that goodwill to be like, oh, so-and-so platform, they're stealing our customers, therefore we're not going to be helpful anymore. Like we haven't observed that. Like if anything, like what I think is really cool when you can go to the Apache Iceberg GitHub repo and see in the issues, there's proposals with commenting across, like all of these who are like would-be competitors are all like cooperating on like building a standard out for the long term, which is like really, really meaningful.
One of the interesting things that I took away from this quote was that, and you're right, I agree. The Git history on the Iceberg repo is fascinating and wonderful. But there's like this concept in this quote of the treaty is valuable not because of the terms, but because of the goodwill that it creates. And so in some ways in that world, Iceberg is more than a set of technical standards. It's more than code. It is like the collective agreement that we want there to be something Iceberg shaped in the universe. And this makes me, the reason I bring this up is that it makes me think about Duck Lake, because when Duck Lake came out, the original post, which went to the top of Hacker News and is like very, very widely read, was all technical in it. Like all of the arguments were technical, but maybe the conversation around Iceberg isn't fundamentally a technical conversation. Maybe it is an industry structure. And the important thing is that like we are all trying to do something together here.
Yeah, and I think in Duck Lake you can read it, and it brings up great challenges with the current Iceberg spec and how it's implemented technically, and says like and it's about the metadata service that we spent a lot of time talking about, right? Like, does it make sense for us to create like oodles of JSON every time we make a new table, or should we just like insert rows into a database because this is what we're familiar with and that's what databases are good at? I think like, hey, those are all valid points, but like what I feel like is missing, and I'm sure like Hannes and Mark like are on board with this, and is when I say that we are all about like data interconnectivity, right? And that's where I get most excited about like the Iceberg REST like catalog API interface, is to say like how might we connect to things. And like when I speak to people at DuckDB Labs and MotherDuck, like they talk about Duck Lake might have like could at one day soon have like an Iceberg REST catalog API in front of it. And so in this point, it's like this is an implementation detail. Like I feel as if like Duck Lake is still within the framework of what you're saying, is like this is a direction and a thing that we want to exist, like this inter-catalog, inter-platform connectivity. And it's like it's almost like a distraction when I see posts being like Duck Lake is better at this and Iceberg is better than this, and don't forget about it's all a distraction. Like we're here all to work together better.
I love that. How about this as a way to wrap this up? Why don't you share I don't know, 1, 2, 3 things that you are excited or hopeful for over the coming year in the Iceberg ecosystem?
I think there's one proposal that you can check out that's more about like how do we efficiently get information from the catalog, and they're talking about like having like sort of like streams of push driven updates. So instead of like select star from all my catalogs in this external Iceberg table and having to make an API call for every single one of them and then validate it against what you have, like you can kind of just like subscribe to like, here are the updates to the catalog. And that makes sort of like the mirroring of metadata between platforms like a lot simpler. There's another big concern, there's sort of like this reputation that Iceberg has is like, this is for big data. And if you have small data, like it's not worth your time and it's too much of a headache because there's actually these performance limitations. And like you see some of that with like folks who talk about Duck Lake. But I think like there's sort of like this small files problem that's like called inside of the Iceberg community. Like I think this will be dealt with, and like there's many discussions about it. Like this will come out in the next spec. I'm excited for that to be like a non-issue. So I'm looking forward to that to be addressed. I'd say like the third thing that I'm most excited about is like this last mile of being able to write directly to external catalogs. Most platforms now support, oh, you can read from here, no problem, and we'll keep you up to date and you can read. But there's still like this general understanding to be like, we want the one that you're using right now to be like the catalog of reference. Like, so read from there, but then use ours. Like ours has the gravity. I think like if we can see a few more platforms support writing directly to other platforms, like I think that'll unlock a lot of really interesting scenarios. And like, especially in the context of what we were talking about, like, you know, DBT platforms, like cross-platform mesh. Like, I think that'll, I'm excited for those to be non-issues, you know, like these issues have been a socio-technical issue for dozens of years in the data world. But if we're so close now that I can taste it to be like the folks who start in analytics engineering, like if I were to ever talk to someone, a new person in data 10 years from now, and they'd hear me talk about how hard it used to move from data platforms, and they like roll their eyes about like this gray hair who's talking about these horror stories. They're like, why are they sharing this? This is irrelevant. Like that's the world that I want to live in, if that makes sense.
I love it. Anders, this has been a lot of fun. Thanks so much for joining us.
Appreciate it. Thanks so much, Tristan.